Mrs. Stanley here. Let's talk about logarithms. This is a review from Algebra 2, but we would jump right in from the beginning. What is a logarithm? It's another way of writing exponents. You can see right here, log base b of a equals x. And in case you don't remember how to say it, is right here at the bottom. And what that means is the same thing as b to the power of x equals a. So we're going to go through here and just do some practice. First thing or second thing we want to know is what's called a common logarithm. A logarithm with a base 10 is called a common logarithm and can be written without the base. So log base 10 of x would just be written log x. If you see a log without a base, that means it's a log base 10. Just need to get that in your memory. So coming down first, we're going to convert between forms. Let's change it from an logarithmic form into exponential form. So looking at the first one, the base is 7, the exponent is 2, and it equals 49. You can test this because does 7 squared equal 49? Yes, it does. Now what's the next one that we have here? Log base 2 of 32 equals 5. The base is 2, the exponent is 5, it equals 32. If you're not sure, test it out. You could put 2 to the 5th power in your calculator, or you could sit here and calculate 2 times 2 times 2, and so on. Look at number 3. Number 3 doesn't have a base on it. What did we already learn about the common logarithm? That means the base is 10. 10 to the 3rd equals 1,000. Is that true? Yes, 10 times 10 is 100, times 10 again is 1,000. Looking at the next one, the base is 4. The exponent is -3, and it equals 1/64. That makes sense because the negative exponent is what gives us the reciprocal. Looking at number 5, the base is 8. The exponent is 1/3, and it equals 2. Think about that. The power of 1/3 means the cube root. So what is the cube root of 8? It's 2, because 2 times 2 is 4, times 2 is 8. What about this one? Log base 9 to the power of 3 squared. Sorry, I mixed it up. Log base 9 of 27 equals 3/2. So we've got 9 to the power of 3/2 equals 27. You could test that. It's like 9 cubed and then the square root. What's the square root of 9? 3. 3 to the power of 3 is 27. So it works out both ways. This time we're going to go backwards. We're going to write each equation in logarithmic form. So we have 5 squared equals 25. Well, hopefully you remember in exponents, the base is what's being raised to a power. So we still have the same thing. Log base 5 of 25 equals 2. Looking at the next one, they bring in a 0, but that doesn't really matter. Log base 8 of 1 equals 0. Well, how would that work? Anything to the power of 0 equals 1. That makes sense. Look at the next one. We've got a log base 3 of 1 over 81 equals -4. Right now, all we're doing is putting everything in its proper place. This one looks a bit more complicated, but just remember, all we're doing is writing it in its proper place. So we have a log base 12 of 2 square roots of 3 equals 1/2. Okay? This one, we have a base of 10, and it's 10 to the power of -1. So we're going to do log base 10. Remember, we don't write the 10 of 1/10 equals -1. That makes sense. And the last one, we have a log base 16 of 8 equals 3/4. Very good. Now what's the next thing? Evaluate the logarithm using your knowledge of exponents. So this time they didn't give us all the parts, so we need to find the missing part. In this case, log base 6 of 36, it's like equal to x, and we need to know what is x. So if we rewrite it, it's a base of 6 to the power of x equals 36. This is a simple enough one. What power? 6 to what power equals 36? 6 squared is 36, so x equals 2. Looking at the next one, you might not know this one by memory. It's 2 to what power equals 128? Well, one option is to just multiply 2 times 2 times 2 times to equal what? Also, we had one back here that was 2 to the 5th equals 32. So we know that's not it, but if I do, that was to the 5th power, to the 6th power would be 32 times 2 is 64. Then to the 7th power would be 64 times 2, which is 128. So that right there is enough to tell us that it's x to the 7th, okay? So 2 to the 7th, so it's x equals 7. All right, let's look at the next one. We've got a log base what? Log base 10 of 1 over 100. So this is like 10 to the x power equals 1 over 100. How would we figure that out? Well, let's think about it for a moment. To get it to the 100 to be in the negative, that's like 100 to the power of negative 1. Well, what could we raise 10 to the power of? If we took the square root of 100, that would be 10, right? So it's actually 10 to the negative 2 that would give us 1 over 100. So we don't need to write that out, but that's just a way to think through it. The answer is negative 2. 10 to the power of negative 2 is going to give us 1 over 100. Now don't worry, we are going to learn a way that you can figure this out when you don't just already know the exponent relationship. But for now, we're just doing ones that hopefully we can figure out in our mind. Log base 16 of 2. So that's 16 to the x power equals 2. If we have a base that is a bigger number than our answer, we know that the x has to be a fraction, right? Because we need to take a root to get a smaller number. Well, what root of 16 equals 2? Well, let's see how we could get 2 up to 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's 4 times. But since it's got to be a fraction, it's going to be 1 over 4. So we could write that a little bit smaller if we want it to look like it fits. Then we go to number 17, log base 3 of 1/27th. So that's going to be 3 to the x equals 1 over 27. We're in another situation where we know it's going to be negative. 3 to what power gives us 27? 3 times 3 is 9, times 3 again is 27. So x equals negative 3. The negative is what gets us in the denominator. And finally, we have log base 8 equals 1. This one's not going to be too difficult. What power would we raise 8 to give us 1? Anything to the power of 0 equals 1. So x has to equal 0. Now let's look at a formula. It says right here, some logarithms are not as easy to evaluate as those above and will require the change of base formula. So look at this. Log base b of a can be calculated by doing log a over log b. Now I'll go ahead and let you know you're going to want your calculator for this. No need to try to do this in another way. Your calculator has a log button and you're going to need it, okay? So, okay, in the calculator you're going to do this number 19, log base 5 of 34. Remember, this formula is up here for you to follow. So we're going to do log 34 over log 5. When you put this in your calculator, you're going to see automatically on the screen it says log and it has a parenthesis. So when you type into 34, you're going to need to close that parenthesis and then do divide log. It'll put a parenthesis, you need a 5, and then you can close it and push enter, okay? So that's going to be important that you are finishing that parenthesis in order to get the right answer. Okay, so log 34 over log 5, does it tell us specifically where it wants us to round? It does not. So we're going to practice just like on the AP calculus in that class. We have to do at least 3 decimal places. So let's just go to 4. We'll just get into practice of having long decimals. So this one we're going to have log 98 over log 2. And that's going to equal, put it in your calculator, 6.6147. And then here we've got log 4 over log 20. Notice which one is going on top and bottom. Whenever you are ready, you could just fast forward, finish some on your own, check your answers, and go on to the next section. Log 2 over log 6 equals 0.3869. Make sure your decimal is clear to see. This one is log 225 over log 3, and that's going to equal 4.9299. I did all of these in my calculator before we started so that I already knew for sure what the answers were, if you're wondering how I'm doing that so fast. So if you need to pause and do it in your calculator, that's what I recommend. If you haven't tried it yet, do it yourself. Log 8, this one in your calculator, you're going to get a whole bunch of repeating 3's, and since it repeats on forever, we can just write it as negative 1/3. Now we have one more thing, the natural logarithm. This is an important piece of information. Maybe you remember it from Algebra 2. It says a logarithm with base e is called a natural logarithm and is written as ln. So log base e of x is just ln x. That's how we write it. If you remember the letter E, it represents a constant value, just like pi is a constant value. So it's just representing a number that's a decimal that just continues on. So write each equation in exponential form. So log base x, natural log of x equals 4. What is the natural log? It's a log base e. So this is e to the power of 4 equals x. That's how you would convert that. Basically, you could see that it's log base e of x equals 4, like this. Okay, so we could rewrite it like we did at the beginning. So natural log of 10 equals x. This is not a log base 10. This is a natural log. It's a log base e. So it's e to the x equals 10. Now in the next one, we're going to write it in logarithmic form. We have e to the x equals 50. Look at number 25 and 26 as your examples, or go back up here where we wrote it out, okay? So we have a log base e, which we write as natural log of 50 equals x. Pay attention to where the x is located. So this is natural log of 50 equals x. And the next one says e to the power of 0.5 equals x. So again, I know it's a natural log of x equals 0.5. Okay? Now the last two we're going to get to calculate. We're just going to use our calculator actually. Right underneath the log button, there is a natural log button. So the natural log of 64, it is going to add a parenthesis, so you'll want to pay attention to that. It equals 4.158, and we'll round it off at 9, 4.1589. And then you can do natural log of 1/3. You would just do 1 divided by 3 inside the, after you push the natural log. So it's a natural log of 1/3, and notice that that gives you a negative. Natural log of 1/3 equals negative 1.0986. Okay? So this is all the examples. You're welcome to move on to the practice page so that you can do some of these on your own. Thank you.